topic is the relationship that Oreskes proposes between science and Pascal's wager. She says that we should think about the relative risks involved in science in terms of Pascal's wager. So to understand what she's talking about, we need to understand Pascal's wager.
So Pascal's wager, what is it? Pascal says God either is or isn't. God exists or God doesn't exist. How will you bet? Are you going to place a wager that God exists, or are you going to place a wager that God doesn't exist? And Pascal says, once you look at the payoffs, it's obvious which thing you should choose. So part of the reason this analysis is famous, because with it, Pascal gives us one of the first influential accounts of what's called expected utility theory. Now, if you're one of my PPE students, you are going to get tons of expected utility theory over the next 3 years. You're going to spend a lot of time thinking about it and a lot of time using this simple, powerful mathematical formula to solve a lot of different kinds of problems. So, the expected value of a gamble. How do you evaluate the expected value of a gamble or a lottery? Well, the idea is this. The expected value of a gamble is the probability of some outcome multiplied by the utility of that outcome.
So this is the formula for expected utility. The expected utility of x, where x is some outcome in the future, is equal to the probability of x. Okay, for any future event, there's some probability that it will happen. And probability ranges from 0, which corresponds to a 0% chance, to 1, which corresponds to a 100% chance. So uncertain future events have some probability associated with them. There is anywhere from a 0% chance or a 0 probability that x will happen to a 100% chance or a probability of 1 that x will happen. Okay, so every future event has some probability associated with it, and every future event or outcome has some utility associated with it. That's some value that will be realized if x occurs. And utility can be positive or negative. It can be a good thing that x occurs or a bad thing. So again, the expected utility of x, where x is some outcome, some event in the future, is the probability of x, which ranges between 0 and 1. It's the probability that x will happen, multiplied by the utility of x, which is the value of x. Okay, so that is the mathematical formula that Pascal's argument relies on. The expected utility of some future outcome is equal to the probability that that outcome will occur multiplied by the utility of that outcome if it does occur.
So you can see why it's called expected utility. The idea is, how likely is it? You take how likely it is to happen, and you multiply that by the value that you would win if it happened, the kind of payoff that you would get if it did happen. So you need both of these things for risky decisions. Sometimes people talk about risk just in terms of probability. How likely is the thing to happen? That tells you what the risk is. But you need a sense of the utility of the thing too, right? So say I told you there's a 99% chance of A and there's a 1% chance of B. Which one do you want? Well, obviously you couldn't make a decision on the basis of just that information. You'd want to know what A was and what B was. You'd want to know the utility. What's the payoff of the different potential outcomes? Well, it turns out that A is a punch in the face and B is winning the lottery. So that's just to make it clear, to think about the expected utility of something, you have to know what its payoff is. What's the utility? You have to know probability and utility to make a decision about expected payoffs. Pascal takes this very simple, powerful formula of expected utility and he applies it to the God lottery. He says, either God exists or God doesn't exist. And you have to make a choice. Are you going to bet on God? Are you going to believe in God and practice some religion? Or are you going to bet against God existing? So you're not going to believe in God and you're not going to practice some religion. He says, well, you can't know with certainty that God doesn't exist. there's some probability that God might exist. Therefore, you should think about it in terms of expected utility theory and think about it like placing a bet. So he says, let's say, what happens if you bet on God? Well, if you bet on God and God exists, and P here refers to the probability that God exists. And Pascal is assuming that there's some non-zero chance that God exists. We cannot know with absolute certainty that God does not exist. So he says, if you bet on God and God exists, then your payoff is infinite. That symbol represents infinity. You get an infinite payoff. Why? Because Pascal believes in Christianity, and that means that you have eternal salvation. Your soul lives on forever in heaven instead of the alternative, which is eternal damnation. Your soul lives on forever in the tortures of hell. Now, there's also a probability that God doesn't exist, and in that case, you'll get some finite payoff. You won't go to heaven and live in eternal bliss, but you'll live a decent life according to your particular religion. Now, let's say you bet against God. Well, betting against God will involve some finite payoff. Maybe you'll do some things that you wouldn't have done otherwise because your religion forbid it. And if God doesn't exist, there'll also be some finite payoff. You'll get the same benefits, essentially. And so Pascal says, hey, just look at the math. If you wager for God, then the expected payoff of that wager is some probability multiplied by infinity plus some other probability multiplied by some finite payoff. In other words, it's equal to infinity because anything multiplied by infinity is equal to infinity. And the expected payoff of the bet against God is going to be some finite amount, F4, because there's no infinite payoff there. And so he says, look, the math is clear. Sure, you don't know that God exists. Nobody knows that with any certainty. But if you're a betting person, and he assumes that we all are, you should put your money on God, because if you are right and God does exist, you will get an infinite payoff. So the expected utility of that wager outweighs the expected utility of betting against God. So that's the idea, and that's the notion that Oreskes is applying to science. And she says, this is how we should think about the risks involved in trusting science. There's always going to be some uncertainty. There's always going to be some non-zero chance that the science is wrong. So we have to ask ourselves, what are the relative risks of ignoring scientific claims that turn out to be true versus acting on claims that turn out to be false? And so here's the example. You can bet on climate science or you can bet against climate science. And there's some probability, P, that the climate science is true, and there's some probability of 1 minus P that the climate science is false. And so she says, if you bet on climate science and climate science turns out to be true, well, you get a big payoff for everybody because you avoided this massive global disaster where tons of people died and the economy crashed and we had to rebuild the entire world from scratch, anybody who survived the catastrophe. Or if it's false, you still get a big payoff for everyone because you built a better world, you built a green world, you created all these green jobs, and so on and so on. Now, on the other hand, if you bet against climate science and you assume that it's false, and then it turns out that it's true, there's a global catastrophe and everyone's life sucks. Or there's also some chance that it's false and there will be a big payoff for oil companies and for people who invest in oil companies. And so Oreskes is suggesting the mathematics here is clear. If you bet on climate science, everybody gets a big payoff no matter what. And if you bet against climate science, there's one circumstance where everyone suffers through global catastrophe, and then there's another outcome where a small number of individuals get a massive payday. So Oreskes is suggesting that this kind of expected utility theory can be used to think about the relative risks involved in believing in different scientific claims. And this ultimately is the logic behind this famous cartoon. You have the person at the climate summit talking about all the benefits of pursuing a green economy, and someone in the audience says, well, what if it's a big hoax and we create a better world for nothing? And that's sort of pointing back to this fact that if we pursue a green economy, there'll be benefits across the board, whether the climate science is true or not. So that's how Oresky suggests that we should think about these things. And in the next video, we're going to talk about the so-called value-neutral ideal in scientific practice. What does it mean for scientific practice to be value-neutral? And would that be a good thing?